Scientists in the UK have generated the biggest amount of energy from fusion, in the latest breakthrough in the decades-long effort to generate clean, cheap power, by harnessing the reaction that powers the sun. The UK's Atomic Energy Authority announced on Wednesday that a team of European researchers had produced 59 megajoules from a sustained reaction lasting 5 seconds, enough power to boil about 60 kettles, in an experiment at the Joint European Torus facility in Oxford, England. These landmark results have taken us a huge step closer to conquering one of the biggest scientific and engineering challenges of them all, said Ian Chapman, chief executive of the UKIA. JET, a collaboration between EU member states, Switzerland, the UK and Ukraine, founded in 1978, is the world's largest, most powerful operational tokamak machine. The design, pioneered by Soviet scientists in the 1950s, uses powerful magnets to hold a plasma of two hydrogen isotopes, deuterium and tritium, in place as it is heated to temperatures hotter than the sun, so that the atomic nuclei fuse, releasing energy. In half a century of experiments around the world, scientists have failed to generate more energy from a fusion reaction than the power-intensive system consumes. Arthur Torrell, a fusion expert, said the latest breakthrough, which more than doubles the previous energy output record of 22 megajoules, achieved by JET in 1997, was another significant step forward. In terms of power, it's equivalent to about 4 wind turbines. That's close to industrial scale, said Torrell, whose book The Star Builders charts the multi-decade effort to achieve fusion energy. Unlike nuclear fission, when atoms are split, fusion does not produce significant radioactive waste. But the biggest challenge to make fusion commercial is how to sustain the reaction and prevent it from extinguishing. Sustaining the power output for 5 seconds was therefore particularly significant, explained Torrell. That might not sound that impressive, but 5 seconds is an incredibly long time on nuclear timescales, he said. It suggests that the stability problem is under control, which brings them a big step closer to fulfilling the full problem. Fusion energy has plenty of skeptics given how long it has taken to make any significant breakthrough, but its promise as a way to fight climate change has increased interest over the past decade. Fusion power would emit no greenhouse gases, and supplies of the chemical inputs are essentially inexhaustible. There are approximately 5 grams of deuterium in every bathtub of seawater, and while tritium is less accessible, it can be extracted from the commonly occurring metal lithium, or generated in the reaction itself. A small glass of fuel could theoretically power a house for hundreds of years. While JET is one of several large publicly funded fusion projects around the world, private sector money has also been flowing into fusion energy startups at record levels. Total private sector financing had reached more than $3 billion by the end of 2021. Torrell said the JET breakthrough should be good news for fusion startups, some of which are promising to deliver commercial power by the 2030s. This shows private companies that it is possible to do it, and to keep the plasma stable, he added. With technologies, once you know something is possible, lots of people work out ways to get there. Thank you for staying with us. Please hit a like button and also subscribe our channel for this type of news.